Hello friends, welcome to our channel. This is Hansa, and in this video, I'll be solving a question from definite integration. So here is the question that we are going to solve. Just observe the question carefully. Look at the terms which I'm encircling. So when you look at this term, the first thing that comes into the mind regarding the substitution is solving the question by putting x is equals to tan theta. Now, if you want, you can pause your video and try this question using the substitution, and then stay tuned to learn how to solve this question. Hope you people must have tried by putting x is equals to tan theta, and now you know that x is equals to tan theta is actually not going to work here. How we are going to solve the question? Let's start solving the question. Substitution, definitely I'm going to use here. But the first substitution is not the trigonometric one, but I'm going to start my question by putting 1 plus x is equals to a new variable t. Let's see what will happen. Keeping 1 plus x is equals to t converts dx to dt, and accordingly the limits will also change. If I assume that the integral which I need to evaluate is I, then this integral I will now take the form lower limit 1, upper limit 3, ln t upon every x is to be replaced with t minus 1, and dx is to be replaced with dt. Well, this integral finally takes the form 1 to 3, ln t dt in the numerator, denominator t square, all the terms of t together, all the constant terms together. So this is the new form of the question. And definitely it's not like a very comfortable or the standard kind of integral. Why it is not a standard kind of integral? Well, the problematic term in the whole integrand, if you observe, is this ln t. Suppose this ln t is not here, then it's a constant upon quadratic form which can easily be handled. So I'm just thinking about some kind of substitution which will help me in getting rid of this ln t. So let's say I started by keeping t is equals to something. But what is that something? Because not just creating minus of ln t. If you want to create minus ln t, why you want to create minus ln t? Because the idea that is coming into my mind is, I'll rewrite this integral I by using some substitution, which will have minus ln t in the numerator. And then I'll add it to this I integral. Adding them together will cancel ln t. Cancel ln t means you can add the two integrals together only when they have the same lower and the upper limit. So I have to keep in mind while using the substitution this point, which point that the limits must not change. Secondly, the denominator also must not change, because if the denominator is changing, then adding the two integrals is not going to make it a simple expression. So there are three basic things or three important things which we have to keep in mind while thinking about some substitution. One, this ln t is to be replaced with minus of ln t. Second, the limits, lower and upper limit interchange, it's fine, but they should not change. And third, the denominator, it must remain same. So keeping this thing in mind, and the first thing first, that means ln t ko I want to replace with something like minus ln t. So I'm thinking about some substitution like t ko we are going to replace with k by u, where k is a constant, u is the variable. This will create ln t as ln k minus ln u. That's absolutely fine. But the problem is, what is k? To get k, I'm going to the second important point. I'm observing the limits and I'm thinking in the rough, all these things have to be done in rough. So I'm just thinking when I keep t is equals to 1, u ke liye we have two options. Either it must take the value 1 or it must take the value 3. What will happen if I take the first case? In this situation, the value of k turns out to be 1. But if you're taking k as 1, then keeping t is equals to 3 will give me u as 1 by 3, which I don't want. I don't want to change the limit. So k ka value 1 is totally discarded. Coming to the second case, keeping t is equals to 1, u is equals to 3 will give me the value of k as 3. If you keep k is equals to 3, then on keeping t is equals to 3, I'll get u is equals to 1. Absolutely fine. This is what I want. So in the new form, the new variable is taking the limit 1 and 3. Fine. So I decided that k is 3 for the present question. Now we have to verify for the third thing, which you can easily verify that if you replace t with 3 by u, the denominator doesn't change. Doesn't change means it is going to become, or it is going to convert into something like constant into the same quadratic. That constant is not an issue, so you need not to worry about that constant. But as long as the quadratic, we are going to get the same. What will you replace, or what will you write in place of dt? Dt will be replaced with minus 3 by u square dt. So let's go ahead and rewrite the integral I in the new form, where the lower limit has now become 3 and the upper one. ln t has become ln 3 minus ln u. Denominator t is to be replaced with 3 by u. So accordingly, denominator will look like this. Coming to dt, it is to be written as minus 3 by u square dt. There are certain terms which will get cancelled from numerator and denominator. So going ahead with that calculation part, and you will find that your integral will start looking like 1 to 3 using this negative sign. ln 3 minus ln u. Denominator 3 I can take common. It will become u square minus 3u plus 3 upon u square. And here we have 3 by u square. And du. Okay, let's cancel this 3 by u square. And what do we have now? Integral 1 to 3. Using the properties of definite integration, I will be replacing u with t. I'm just replacing u with the same t that I have in the first equation. So denominator t square minus 3u, 3t plus 3, and this is dt. This is the second equation. This is the second equation. From first and second equation, you can observe that two integrals have the same lower and the upper limit, same denominator, only the numerators differ. So I'm going to add the two integrals now. You add 1 and 2. So 1 plus 2. This gives me 2i is equals to integral 1 say 3 ln 3 denominator t square minus 3t plus 3 and dt. So you can see that we converted the question to constant upon quadratic form, which is easier form compared to the original form. Now we are going to solve it exactly the way we solve a constant upon quadratic forms. That means making a perfect square in the denominator and proceeding. So the question is now easier. We are making a perfect square in the denominator, adjusting the constants, dt. Obviously, after making the perfect square, what we do is we use a trigonometric substitution here, which is going to be root 3 by 2 tan theta. So accordingly, dt will also get changed to root 3 by 2 secant square theta d theta. So accordingly, now 2i will look like, instead of lower limit 1, when you keep t is equals to 1, theta turns out to be minus pi by 6. And similarly, when you keep the upper limit 3 over here, tan theta becomes root 3, so upper limit pi by 3. ln 3 is a constant, it won't change. dt will be replaced with root 3 by 2 secant square theta d theta. And using the substitution in denominator gives us 3 by 4 secant square theta. As you can see, secant square theta got cancelled. It's a very basic integral question, which we can solve. So you can see that what we are getting is 1 by 2 ln 3 root 3 by 2 upon 3 by 4, and d theta when integrated, and after putting the limit, it reduces to pi by 2. 4 got cancelled, and answer turns out to be root 3 ln 3 multiplied by pi whole divided by 6. So this is the answer for the question. I hope you enjoyed the question. Thanks for watching. Bye-bye for now.